Hello everyone, I hope that you're doing great today. Now, today we're looking at the noble gases, and we're looking at noble gases in terms of them being p-block elements. All right, we're going to use this concept also to look at a very easy way how to write shorthand electron configuration. Now, the first thing we're going to look at here is the periodic table. The periodic table arranges elements in terms of vertical columns, which are called groups, and horizontal rows, which are called periods. Now, elements are placed in the periods based upon the number of shells, and they are placed in the groups based on the number of valence electrons. Now, if you notice closely, starting from hydrogen all the way over to helium, you'll notice that we have 18 vertical columns. So technically, there are 18 groups of the periodic table. However, I know that in a basic chemistry class, you'd have talked about the 8 groups of the periodic table, and the reason for that is because in those days, we do not count the columns of the transition metals. All right, so we skip over them in terms of counting. And so if you notice here, the second column is called group 2, and skip over the transition elements, we call it group 3. Otherwise is group 13. All right. Now our focus is really on the P block elements. All right. And so our P block elements start from the 13th column all the way to the 18th column. And so this entire section is called the P block. And so the P block elements that fall into this section, they are called P block elements simply because if you draw the electron configuration, you'll realize that the very last orbital to be filled is a p orbital. All right? And so as a proof of this, you can take any of these elements and draw the electron configuration, and you will realize that the last orbital to be filled is a p orbital. However, helium is an exception to this rule, and I'm going to talk about that shortly. All right, our focus is really on the noble gases, so let us shift our focus to them. And so the noble gases, based on how they are arranged in terms of their periods, starting from helium all the way down to octium. Now, what I want to point out here, though, all right, that the periods as how they are arranged is based upon the number of shells, and number of shells represented by n, which is the principal quantum number. So helium is in period 1, which means 1 shell. Neon, 2 shells. Argon, 3 shells. Krypton, 4 shells. Xenon, 5 shells. Radon, 6 shells. And octium, 7 shells. All right? Now, what I want to point out now is the orbital that exists as the very last orbital. So we're looking at the very last orbital for these elements. Now, again, helium is different from the rest because helium has 1 shell, okay? And so if you have 1 shell, which is the first and last shell, the first shell is the last shell, all right? And so therefore, the orbital that occupies that shell is the s orbital, okay? So we can only have 1 s. Now, we talk about these elements being p block elements. However, helium, since it has 1 shell, it can only have an s orbital. All right, so that is the only exception to that grouping. But it is a noble gas because the orbital is completely filled. All right. Now for neon, we have more than 1 shell, so therefore we can start have our p orbitals. And so therefore here we're going to have 2p6. And point to note is that the p orbital holds a maximum of 6 electrons. The s holds a maximum of 2. Let's go back into organ. And so organ here will be 3p6, krypton 4p6, xenon 5p6, radon 6p6, and octium is 7p6. Now, point to note is that octium is a synthetic element, which means you will not find it in the earth that easily or freely. All right, now, why is this important, or how is it important in terms of helping us to write the shorthand electron configuration? Now, it is very important to note that the inner shells of any given element resemble the electron configuration of a noble gas. Now, let us bring this in perspective by using an example. Let's use cobalt as our example. Now, cobalt has 27 electrons, right? So the inner shells resemble a noble gas. To determine which noble gas that is, it is a noble gas that comes before that element. So the closest noble gas to cobalt that is less than 27 is 18. So argon will look just like the inner shells of cobalt. All right? And so the inner shells represented by argon, let's put argon there as our representation of the inner shells of cobalt. Now, what you want to note now is that the difference between argon, which has 18 electrons, and cobalt, which has 27 electrons, the difference is 9 electrons. So what we have to do is to account for those 9 electrons, all right? Now, how are we going to do it easily is to use our orbital filling chart. And so let's put that up real quick. And so remember now that argon is at 3p, okay? So let us highlight 3p. And remember that 3p will be totally filled, so therefore we have to go on to the next orbital, which is 4s, okay? And so what comes after 3p is 4s, so let's put our 4s, and 4s could hold a maximum there of 2 electrons, and we're working with 9, so we have 7 more to be accounted for. And so after 4s, we can go on to 3d, all right? So remember, it is head to tail for the arrows. Now going on to 3d, d holds a maximum of 10, but we do not have 10, we only have 7. So therefore, we're going to put our 3d 7. And so this is the electron configuration of cobalt. However, we can rearrange these two shells, because remember now the number here represents the third shell, this represents the fourth shell. And so we can rearrange them in terms of increasing number. And so therefore, we can rearrange it to say argon 3d7 and 4s2. And so either way, they are correct. All right. However, the last one would be the most appropriate in terms of shells, if you consider shells rather than orbitals, right? Now, the bottom line is though, if you count the outer electrons, which are technically the valence electrons of cobalt, so there are 9 valence electrons for cobalt, all right? Cobalt is a transition metal. And so therefore, since it has 9 outer electrons, it would fall under the 9th column. So if you go back to the periodic table, you will see where I have it. See, I put a little piece right here for you to see. Cobalt is in the 9th column because it has 9 valence electrons. All right, so I hope this was easy for you and really makes sense in terms of helping you to write shorthand electron configuration and understanding the p block elements. So I want to thank you very much for watching this lesson, and I also want to tell you that gratitude is the sign of noble souls. So please have a wonderful and blessed day, and I will surely see you soon. Take care.